Assalamualaikum everyone. You see, we are all in a state of quarantine. My shave is going really wild, and my tummy is also going out. Okay, so never mind. Let's hope for the things to get better, inshallah. Okay, so moving towards the exercise 3B, we shall see that how these F equal to MA and then this G thing and then R thing, they would be modified after learning that resolving the forces thing. Okay, now the first thing is that if you just recall that thing, that if there is an object, let's say its mass is 2 kilogram and this is being pulled by a force of 10 newtons, yes, then using this F equal to ma, we can find the acceleration. This is 10 equal to 2a, so the acceleration is 5 meters per second square. Now, what if we have the same force, but this is instead of being a horizontal force, now this is inclined at an angle of, let's say, 60 degrees over here. Okay, so now this is the same 10 Newton force, but now you will have to resolve this force parallel and perpendicular to the direction of this motion, okay, of this acceleration. So when you resolve this, you get this is going to be 10 cos 60 and this is going to be 10 sine 60. Okay, so when this object is moving on a horizontal line in a horizontal direction, we're only interested in this horizontal force, component of force over here. Okay, now this F equal to ma would now rather become 10 cos 60, that is equal to the mass which was 2 kilogram, that is going to be equal to 2a. Okay, now we know that cos 60 is half, so this is going to be 5 equal to 2a, and acceleration is 2.5 meter per second square. So you see, we have to resolve your force so that you know the component of the force which is parallel to the direction of the force, direction of the motion. Okay, now what is the role of this component over here? Right now we don't need this. This will later on help us to find the R, this R, the normal contact force. Okay, and nevertheless, if you just generalize this formula, which was F equal to ma. Now if this is simply F and this one is theta over here, then this component is going to be F cos theta and this is going to be F sine theta. Okay, so now that F equal to ma changes into F cos theta equal to ma, where this F cos theta is the component of the force which is in the direction of this acceleration. Okay, now some people they get confused about this. Like you see, there is this weight as well, which is 20 Newton. So what is the impact of this 20 on this acceleration? So if you see that this angle over here is a right angle over here, okay, and you know that cos 90 is 0. So you can note it down in your notes that a force which is perpendicular to the direction of the motion has no impact on the acceleration. Okay, so the force has to be parallel to the direction of the motion. Okay, I'll come back to this F equal to ma thing again. I have to tell you a bit about this G, that what happens to G when something is moving under gravity but it is moving on an inclined surface. Okay, now suppose there is this object, whatever its mass is, if it is falling down vertically, its acceleration is g, okay, g meter per second square. If it is going up, then the same one is going to be g meter per second square. Now what if this same object is now moving on a horizontal surface and purely under gravity, there is no driving pulling force, there is no resisting force on it. Okay, now suppose this is an inclined plane. This is like the cross section of any incline, that can be a road, whatever. Okay, so here is an object rolling down this surface. Okay, now this is a very important kind of a diagram now going to start, and If you're clear about this, you will become a champion of this mechanics. Okay. Now, in fact, this G had to be in this direction. Obviously, G is always directed towards the center of the earth. Okay. Now, we have to find the component of this G which is parallel to this direction. Okay. Now, what do you think? Like, while rolling down, will it still have the acceleration exactly equal to G? Will that be less than G? Will that be more than G? And what if, like, if there is a less incline, like, for example, if it is lying on this, if this is lying on this surface, and if it is lying on a surface which is like, much steeper, if there is another surface which is even steeper than this, okay, and ultimately, like, you have, you see this dropping from exactly in a vertical direction, okay. So here this G would be exactly G, which is 10, okay. But if you keep on decreasing the steepness of the surface, so you can yourself understand that this, when it is lying on this ground, obviously this is at rest, okay. So the magnitude of this G, that depends on this theta over here, that how much inclined is this surface, okay. So when you have to determine the value of G, then please look at this. This is a very confusing kind of a diagram, okay. So this is like this is the object over here, okay, and here is it. If it was allowed to fall freely under the gravity, it had to go in this direction. But now this is placed on an inclined plane, which is inclined at an angle of theta degrees. Okay, now please look at this very carefully. I'll draw a line passing through this. Now this line is, please see this line is perpendicular to this surface basically, okay. I have to draw a line perpendicular to this surface, and at any point, like, wherever you think, like, I just cut it down like a bit shorter, and you draw another line which is parallel to this surface, okay. So we are basically going to resolve this G perpendicular and parallel to the surface on which this object is, this particle is moving, okay. Now look at this. Just going to tell you this time, and next time I'll directly be writing this theta over here. Now this is a right angle over here, okay. This angle is going to be 90 minus theta. I'll not be writing it, okay. This is 90 minus theta, this one. So what would be this angle if there is a right angle over here? Yes? Yeah? Yeah, this is going to be theta, okay. So if this is theta, then this is going to be theta. Look at this once again. If this is theta, this is right angle, so this is 90 minus theta. And this is already a 90 degree over here. So if this is 90 minus theta, then this angle has to be theta, okay. Now as you have learned the resolving of the forces. Now this is going to be G cos theta, and this is going to be G sin theta. Can you see this? So, if you have a particle, an object moving on an inclined surface which is inclined at an angle of theta degrees, then its acceleration, which is due to that gravity, that is going to be G sin theta. If this is going upwards, then the same acceleration would be minus G sin theta. Okay, got it? You have to see this again and again, and you have to learn that how we're determining this thing, okay. Now I'm just going to erase this. I'm going to go towards the R thing now, okay. So you have seen that your formula, the newer version of this, F equal to ma, that has become now F cos theta equal to ma, okay. And your G is now G sin theta. This is because here the force was an inclined force, and here this G was because of the object moving on an inclined surface, okay. Now we have to see how to find this R, okay. Yeah, this is really important, okay. Finding the value of R. You see guys, in your whole of mechanics, your objects, they would either be static or they would be moving, okay. So like if they are moving with the constant speed, or if they are at rest, in both of these cases, it means that the resultant of the forces on that object is 0, okay? And if the object is being accelerated, then that resultant is going to be equal to ma, okay? And when you talk about the resultant of the forces, definitely the resisting force would come there, okay? And to determine the resisting force, there is a formula that I'm not going to tell you right now, I'm just going to note it down. That is F equal to mu r. For this, to determine the resisting force, you need to know the R thing, the normal contact force, okay? So now let's see how to determine the value of R. You guys already know that if there is a horizontal surface, okay, and there is an object lying on it, if its weight is 10 Newton, so here this R is going to be 10 Newton, okay? This R is exactly equal to 10. If you're going to pull this up with a force, let's say there is a force of 4 Newton. So I believe you guys know that now the R is going to be 6 Newtons, okay? Now, what if you have an inclined force over here, okay? I'm just using this 30 degrees and 60 degrees again and again because right now I don't have my calculator in front of me. Yeah, it is here. Oh, now I can use any of the angles, okay. Now suppose this is 30 degrees and there is a force of, let's say, 10 Newtons. Now guess how much would be R now? Would that be R plus 10 equal to 10? Or what? Yes, you will have to resolve this 10 Newton force parallel and perpendicular to this surface on which this object is lying, okay? So when you resolve this, you get this, it's going to be 10 cos 30 and this is going to be 10 sin 30. For a moment just forget about this 10 cos 30. Now let's see how to find this R in this case. Now this R is going to be R plus 10 sin 30. R plus, any guesses why did I use this 30 degrees? Yeah, because I didn't have my calculator with me and sine 30 is half, okay? R plus 10 sine 30 is going to be 10. So you see this is sine 30 is half, so this is 5. So this R is going to be 5 Newtons. Okay? Now I'm like, adding on situations over here. You have to be very good at finding this R. Okay, now a typical diagram that you will be seeing many times in your past papers and in your textbooks question. Now here is an object. Let's say this is inclined at 10 degrees, okay? Now the mass of this object is, let's say this is 5 kilograms. We want to know that what is the normal contact force right now, okay? Now please remember, if I push it down and this is pushed down, this comes over here, okay? So this object is on the ground like this. So if this is the weight over here, 50 Newtons, then this is going to be R. If I rotate this up to this, now the weight is still directed downwards, okay, which is 50 Newtons. But R would be directed in this direction. This R is basically the normal contact force. The normal means the right angle. A force which is perpendicular to this surface. Basically, because of the weight of this object, the reaction on this block, whatever, of this surface over here. Okay. So we need to know that what is this R. Okay, I hope you're getting this point that this R is going to be like this. If your object is lying on a horizontal surface, the R would be, a vertical force. And please see, we are going to see the situations where you will have, for example, there is a vertical rod and there is a ring over here, okay, and you are pulling this through a string. So in this case, can you guess in which direction would be the R? This is our object over here, okay? So you're pulling it in this direction. So the R would be in this direction because of this object being intact with this rod, okay? So this is always perpendicular to the surface on which your object is lying. Now you see, I have to extend this line over here like this, and I will draw a line here. Please remember this you can draw this diagram very easily if you maintain a right angle over here like this. And then when you maintain this right angle, you maintain the right angle here as well. If you do this, this component would look exactly parallel to this surface, and this component would look exactly perpendicular to this surface. Okay, so since this is the weight going downward, so I would be directing this in this and this. And again, if this is 10, I have to mark this angle as 10 degrees. Okay, so guys, here now this is going to be 50 cos 10, and this is your 50 sin 10. So your R right now, that is equal to 50 cos 10. You see, R is 50 cos 10. Okay, you can change different values and you can find this R. Okay, now suppose there is a force, there is a string, and there is a tension of, let's say, 10 newtons in this string. Now, will there be any change in the value of R because of this 10 Newton force here? Yes? No. There will be no impact on this R because this 10 Newton force is parallel to this inclined plane where this object is going to move. Okay? So this R will only change if there is any force which is perpendicular to this surface on which this object is going to move. Okay? Now suppose there is a 10 Newton force now over here. Okay, this is 10 newtons, and this is acting at an angle of, let's say, 20 degrees. Now let's say you have to find this R. Okay, so now this is not a difficult thing, you will resolve whatever the forces are, you only have to resolve them parallel and perpendicular to the surface on which the object is going to move, or in other words, parallel and perpendicular to the direction of the acceleration if there is any. Okay, so basically direction of motion ke parallel and perpendicular, you have to resolve whatever forces these are, be it the R, be it the weight, the driving force, the pulling force, the frictional force, whatever you have. Okay, so now this is going to be 20 sin 10 over here, and this is going to, this is 10 sin 20, and this is 10 cos 20. Okay, so you see this R plus this 10 sin 20 is going to be equal to 50 cos 10. So now R is going to be different as compared to the previous value. So now this R is going to be R plus 10 sin 20, that is equal to 50 cos 10. Okay, now I'm going to give you some situations from my own so that you can try to find this value of R. Can you please pause this? Okay, so you must have your copy and pencil with you. Never sit without the pen in your hands. Okay, now you try finding R in these 4 cases. Okay, so I'm telling you again, you will only understand this if you have tried it yourself. So you must pause the video and then you must try them, and then you just match your answer. So I'm going to tell you what are the values of R in all these cases. So in this case, this is the only force R over here, so R is 20 over here. So R is going to be 20. In this case, it is R plus 10 equal to 20, so your R will be 10. In this case, we'll have to resolve this, okay? So this is going to be 30 cos 15, and this is going to be 30 sin 15. So your R plus 30 sin 15, that will be equal to 20. So that is how you will find this R. And in this case, if you resolve it, parallel and perpendicular, so this is going to be 30 sin 15, this is 30 cos 15. This is a very different situation here. Now there is just one force R upward, there are 2 forces downward, okay? So this R in this case is going to be 30 sin 15 plus 20, okay? So this is how you find R. These are the easier cases. Now I'll be giving you some question where you will have to determine this R on the inclined planes. Okay. Okay, now guys, these are the inclined planes over here. Okay. All these blocks, they have a mass of 2 kg, and This is simply lying on this, okay? So you have to find R. This B part, the same block is being pulled upwards, okay, with a force 10 Newton, and this force is further inclined on this plane at 15 degrees, and here let's say this is 20 degrees over here, the same block, but this time there is a horizontal force. We are pushing through this horizontal force, okay, and you have to tell that how much is R in this case, and here we are again pushing this, but this is not a horizontal, parallel force, horizontal force, but this is basically inclined at an angle of 30 degrees from this plane, okay, and let's say this angle is 40 degrees. So please try to find out the R, okay. Okay, now you have to see how I am going to find this R, but the condition is again, you should have tried it yourself first, okay, otherwise it is simply useless to find this R, okay. So some of you were saying that this it has to be more interactive, so that is how I can interact with you guys. So please, you should have tried it before you see how I'm going to find this, okay. So I'm supposing you have tried it, so you should have shown weight over here. This is the weight, which is 20 newtons, okay, and you keep your pencil over here, you draw a line perpendicular through this, okay, perpendicular to this surface, and then here you draw a line, okay. Now if you maintain a right angle over here and a right angle over here, you will have a very good diagram, a good force diagram, okay. Now this is your R, okay, and this R is going to be, you don't even need to mention this angle 20 degrees. This is understood now that this is 20, so this angle over here is 20, so this is going to be 20 cos 20. So this R in this case is going to be 20 cos 20, okay. Going towards the second situation, again here is the weight, which is 20 newtons, okay, and you keep your pencil over here, you draw a line like this, and then you have a line like this. So again, if you have maintained, you don't need to show this right angle, I'm just showing this so that you just try to understand that how can you have an accurate diagram, okay. So this is 30, this angle is going to be 30, so this is R over here, this is going to be 20 cos 30, and I don't need to write this right now, okay, because I don't need this component for this R, okay. Now this is going to be 10 sine 15, okay guys. So now this R plus 10 sine 15, that will be equal to 20 cos 30. That is how we will find R in this case. R plus 10 sine 15, that is equal to 20 cos 30, okay. Now the C thing, again the weight is 20 newtons over here, okay, and here is the R. Now this time you see that again you should be used to it now. This is like this, and this force is 20 cos 20 because this angle is 20 degrees. Now this force is not at all parallel to this inclined plane, okay. So we need to resolve this. So I'll be resolving like this. This is parallel to this surface and this is perpendicular to this surface. Please guys, yaar, सीख लो इसको यार, okay. So if this is 20 degrees, I can mark 20 degrees because of the alternate angles, okay. So this is 10, this is going to be 10 sine 20, okay. So now this R is going to be R, that is equal to this 10 sine 20 plus this 20 cos 20. This is for this part, okay. And finally coming towards this D part, okay, let me use a different color so that it looks a bit colorful. Okay, now this is again 20 newtons, okay, and I keep a pencil here, and this is your 40 degrees here, okay. This is your 20 cos, I hope you can see this. This is your R, okay, and when I resolve this goes down, this goes like this. This is 20 sine 30, and I don't need this right now, okay. So this R is going to be, R is equal to this plus this. Can you see that? Okay, so this R over here is 20 cos 40 plus 20 sine 30. So guys, many of you are trying the questions from the textbook. Right now there is no need to try any question from 3B. I will do those questions for you first, okay? But for God's sake, you practice this thing. Once you're clear how to find this R, then believe me, there's going to be no problem in your mechanics, okay? Thank you, take care, Allah Hafiz.